This is the question on chapter 14, worksheet 1 and question number 5, 5a on the DC circuit. There is a mixture of series and parallel circuit in this question. So I want you to master the heuristic or even the way to solve this kind of problem first. Question A give you a simpler task to start with to calculate the total resistance in the circuit. In this question, there's a hint given to you that to solve the total resistance in the two parallel circuit, which is the 80 ohms and the 50 ohms resistors here. So you may go ahead to solve this first, then add to the 100 ohms, which is the resistance which is in series. Of course, now I think you know that these two parallel resistance can be resolved by using the inverse law. It's called it will be solved like this. It's a negative power of a 1, and then to solve this problem, right, we just get R total equal to the 100 ohm plus the total resistance in the parallel circuit here, which is equal to this entire thing in bracket and with the power of negative 1. So it's 1 over 80 plus 1 over, which is you learn where 1 over R equal to 1 over R1 plus 1 over R2. Just to recap, this was the parallel resistance formula. So in this case, it will work out to be 131 ohms of the resistance. Right, this is a pretty simple thing. Then of course, now we know the total resistance in the circuit is 131 ohms, and we, from what we know about the EMF and also the total resistance, actually we can calculate the total current in the circuit. Okay, let's look at question B. Okay, question B, that when we work on this, I already work out the details here. Let me explain that using the formula I equal to V over R, then I total, which is this, the I total, which is flowing from the cell, right, to the entire circuit, and then back to the cell, equal to, of course, the EMF divided by the total resistance. Because the EMF is the total PD. Okay, it works out to be 12 volt divided by 131 ohms, and it works out to be 0.0916 ampere. So 0.0916 ampere is actually this. That's flowing out from the source. And we can see that the 100 ohm resistance also receive or have the current equals to 0.0916 ampere, right? So I will say that I will label it here. Okay, put it here. So because the next question, right, ask us to even to calculate even the current flow through each resistor, right? So we need to work out one by one, because now we already have this 0.0916, which is the current flowing through the 100 ohm resistor. Okay, let me repeat and go refer to the diagram again. This is the one. Okay, we solved this already. Next is to find out the current flowing through the 80 ohm resistor and the 50 ohm resistor. However, right, we only had resistors, but we need to have the potential difference or the PD across the 50 and the 80 ohm resistor in order to find out the current, right? So we need to work it out. But from this diagram, actually we can work it out, because we already know two things. Number one is the EMF. Yeah, EMF of the source, and we also can work out the potential difference across the 100 ohm resistor, which is equal to Ri, which is equal to the 100 multiplied by 0.0916 ampere, which is equal to 9.16 volts. Yeah, so now things appear to be a bit clearer now, right? So this is step number 2, right? So step number 1 just now showing you already. Step number 2 be like this. And we also learned that the potential difference across the entire circuit actually add up to be the EMF. So you add up to be the EMF. Here, the 80 ohm and the 50 ohm resistors will have the same potential difference because they are parallel, and they are also equal to the difference of the 12 volt and minus 9.16 volt. Because later on you show it to you again, 12 volt minus 9.16 volt, right, will equal to 2.84 volt. And since the 80 ohm resistor and the 50 ohm resistor is actually parallel, so the V, or the potential difference across the 50 ohm resistor, will have the same as the above, 2.84 volts. Yeah. Now, it appears to be a bit clearer now, right? That we find the potential difference across 80 ohm resistor and 50 ohm resistor, and we can actually, using the V over R, we can find the I through the 50 ohm resistor and the 80 ohm resistor. Okay, now let's work out from the top first. So I have the V equal to 2.84 and the R equal to 80. Therefore, I can find out the I here. Okay, V over R equal to 2.84 divided by 80, which is equal to 0.0355 ampere. Yeah. So we are pretty near to the last already, because now after working out the current flowing through the 80 ohm resistor, now is to find out the current flowing through the 50 ohm resistor. There are two methods. We can use the same method like above. For example, we use I equal to V over R. This is method number 1, which is equal to 2.84 divided by 50, which is to give us 0.0496 ampere. Or we use this method of the current that is flowing. Look at this branch here. Okay, I'm going to highlight here. The current flowing through the T branch has to be following this rule. Okay, I1, I2, and I3, right? Okay, which is I1 equal to I2 plus I3. Yeah, because what comes in must equal to what goes out. So since we just now we can work out the I3. I3 equal to I1 minus I2, which is equal to 0.0916 minus the above 0.0355. Okay, let's work it out. Okay, does it equal Let me calculate one more time. Which is equal to 0.0561. Okay, so okay, my calculation here is a bit off. Okay, let me see what went wrong. Alright, my previous, I think I made a mistake here. Yeah, 2.84 divided by 50 should be 0.0568. Yeah, so you see the difference. There is a slight difference, but I think because of the rounding error. Yeah, okay, so these two methods, just now I said either using the first method or the second method will give you pretty the same answer. Actually, it's the same answer, just because of the rounding off, it is different. All right, I hope that through this video you are able to like practice more questions, and based on this method of solving the DC circuit problems, that you will excel in solving problems in different type of questions. Thank you very much.